So there's other types of information that are of concern in science. The first of which we list is fallacious information. And this is the examples that we like to use here are Lysenko's claim as Stalin's biological science director that Mendelian genetics was wrong and that he had come up with a new system of genetics, which led to incredible political turmoil, ending in the deaths of a lot of people, the incarceration of people over not even category 3, but fallacious thinking in science. There are lots of other examples. I love to use the one of extrasensory perception, ESP. So there were serious, legitimate investments by government into extrasensory perception. And so what the claim here is that you can have apperceptions devoid of the perception. That is, avoiding the sensory system, you can still be in touch with phenomenology. Okay, interesting. And at no less than Duke University, an institute was set up under Dr. Rhine, R-H-I-N-E, to do serious studies about extrasensory projection. As a naval officer, program manager at the Office of Naval Research, I had very forceful and almost legitimate proposals to extend research to military extrasensory perception. And I was given an example of a piece of artwork that was done in Europe while someone was thinking about something here in the United States, and there was a connection. And you know, the scientist immediately says, okay, I'll take you for your word that that experiment happened. What is the mechanism? How did it happen that from this person's imagination and it ended up on this person's piece of paper? He said, it's irrelevant. No, not to a scientist. We have to know the mechanism. How did that work in physics? What military would not want to exploit ESP? If they could get into the minds of their adversaries and so forth, my God. Well, so during the Reagan years, as I say, I can't go into detail here, but there was an effort by the West to demonstrate, falsely or otherwise, success in ESP in order to, there again, help spread the Soviet investment in counter technology. And so, you know, I guess, and I was involved in it. So we had no confidence that ESP worked, but it was worth the investment to spread them out. The best experiment that I think of with regard to ESP was, have you heard of Corellian forces? That our bodies expel these Corellian forces that can be defined in physics. So the critical experiment that was done was a husband and wife team who could read Corellian forces on people, right? And which is better than, I guess, palm reading. So the experiment was the two were seated next to each other, separated by a panel, and a one-way mirror into the room were put subjects, one person after another, and the lights were turned off because Corellian forces don't require reflected light. They emanate from the body, we were told. So the wife-husband team were writing down the colors of the Corellian forces of one subject after another. And number one, there was no correspondence between the two of them. One would find red, the other would find blue. And more embarrassing was the fact that not a single person actually was sitting on the stool. Okay. Extremely embarrassing to the two of them. And so the Corellian forces concept kind of went away. There again, the point is forcing the function of science into as high a trajectory as possible. So back to the basics here a little bit. We'll talk about universal scientific principles. And we'll just spend a slide or two on this. But any scientific study consists of two components. The first is such that unique features of the discipline upon which the study is based. Example, appropriate statistical methods. And this is the beginning of a treatment I'm going to provide on mensuration, or getting the measurements right. The second is application of the universal scientific principles to derive specific results and conclusions. And the example that we like to give here is the application of relevant analytical methods and reproducibility of results. And as I said, I'm going to talk more about that. First, in science, like in law, which uses case law as precedent, we build on the shoulders of others. We continue to experiment, to theorize, to collect data and doubt, but we rely on the trajectory of existing science. Example, scientific engineering projects supported by federal agencies and private industries. So that's cool that we rely on others, that we stand on their shoulders, but sometimes we get it wrong. So I'd like to give an example of how we almost got it wrong. 30-something years ago in a federal laboratory that I know a lot about, they were conducting spring sweeps. What are spring sweeps? Well, the federal budget, which begins in October, and oh, by the way, let's remember the history of that. The fiscal year used to be the calendar year. It used to be January 1, but the government got behind, and they said, okay, the new fiscal year actually begins in April. And that worked for a while. Then the federal government got behind again. They changed it to July. They got behind again and said we have to change the official definition at the beginning of the FY, but then they pulled a trick. It'll be October 1, but we're going to skip a year. So like we're right now in FY 10 in the federal government, right? Even though it's calendar year 9. Okay. Well, what happened in spring sweeps was every year typically in the government, you have your spending plan. Sometimes you're on it, sometimes you're not. If you've got extra money, you want to get ideas for how you're going to fund research. So at this particular federal laboratory, the scenario was all the executives are sitting at the table, and the troops who had an idea that got vetted were bringing these ideas to the decision-making body. So I'll make up names here. The next person is going to be Smith. Oh my God, Smith. Wasn't he in here last year with his harebrained idea? Yep. All right, just get him in here. So he goes through his briefing, and the board said, so let us get this straight. You're telling us that if you put satellites up in space, a person down on the Earth can figure out where they are? And he said, yeah, I've worked out all the math. And this board said, this is not a math problem, son. This is a satellite issue, and you're not a satellite guy. And someone said, you know what? You know, we're tired of it. Let's just give him his $50K and get him out of here. And GPS was born, right? It did not build from the body of knowledge, the shoulders that we typically stand on. It was a different way of thinking about things. And my God, look at the effect of GPS. Look at the effect of someone getting drunk and writing out data protocol units on an envelope and presenting it to the director of DARPA. So although we're making this big claim that we're all about incremental science, very often there has to be a wayward thinker who says, we're looking at this wrong. The second part of this chart is all about what I mentioned before, and that's mensuration. Measuring things objectively and making those measures available is what we're all about here. The next chart is what I mentioned before, is what is the product of science? By and large, it's the production of models, ways of representing phenomenology such that another individual can understand how, why, when, and where that phenomenology operates. And so, again, our request to you is, when we present this as a class to journalists, to policymakers, and others who don't necessarily have a science background, are we getting this right? Is this the way we ought to be tutoring staff and members of Congress on Capitol Hill? We caution them, as usual, to learn to distinguish between causation and correlation. And I have a couple examples I like to use here. The first is, in Germany, there really was found a correlation between population of storks and the number of births that occurred outside of hospitals. So the conclusion was that, yeah, storks do deliver babies, right? Good. we already knew that. It's also true that there is a very positive correlation between the number of ice creams sold in London and the number of heat strokes in New York City. So should President Obama invade England and get to a knock-it-off situation? Now, obviously, in causation and correlation, we teach policymakers to understand there's not necessarily cause. You need to think of a third variable, in this case, the output of the sun, that leads to more ice creams being sold and the more heat strokes that are being incurred. And we'll come back to the sun in a few minutes.